Okay, so a rectangle is constructed with a base on x-axis and two of the vertices on the parabola y equals 16 minus x squared, right? So key information is base on x-axis and vertices on the curve, and we want to find the dimension of the rectangle, maximizing area. So it's a maximization problem. Let's draw that diagram here. So we have the parabola 16 minus x squared. Diagram will be given, if there is a diagram, I will give it in the exam. 16 minus x squared. So it's kind of a parabola. This is at 16. Okay. So there is a rectangle with the base on the x-axis and the two vertices on the parabola. Right. So because an equation is involved, there is an equation y equal to 16 minus x squared. A point on the graph xy satisfies this equation, right? So we're going to choose xy as a point on the graph, and it will satisfy this equation y equal to 16 minus x squared, right? So anyway, now we're going to identify the dimensions of the rectangle using the x and y. So because this value is x and this value is y, so the length of the rectangle is 2x, x on this side and x on the left side, whereas the width of the rectangle is just y, right? So the rectangle is just in this form, 2x and y. All right, so let's formulate the problem. We want to maximize the area given xy on y equal to 16 minus x squared. Okay. So the condition is already an explicit equation here. Rewriting area, maximizing area of that is L times W, which is 2x times y. So eliminate y, plug into to eliminate y. So this problem becomes a maximizing 2x times 16 minus x squared. So we have f of x, the function becomes 32x minus 2x cubed. So we have this function and we want to find the maximum value of this function. So identify the critical points. 32 minus 6x squared equal to 0. So we have solving this, we have 6x squared equal to 32, x squared equal to 32 over 6, x equal to square root of 32 over 6. You can approximate it to some number. Once you get that value, we need to make sure it is a maximum value. So analyze sign of f prime, right? So you have 32 over 6. So you want to find f prime here and f prime on the right side. We are trying to show it as a maxima. So we want to get the sign to be positive and negative here, right? So that the graph goes up and down, and then it will be a maxima. So you want to show this work, first derivative test to identify maxima. So we have maxima at x equal to square root 32 over 6. You can simplify this number, and once we have maxima, we want to find the dimension of the rectangle, right? So x is the, so we want to find the length of the rectangle is 2x, which is 2 times this number, square root 32 over 6. Of course the width is y equal to 16 minus x squared, which is going to be 16 minus square root 32 over 6 the whole squared, which is 16 minus 32 over 6, and you simplify that answer, right? So that will be the length and the width of the rectangle with maximum area inscribed inside this parabola.